Hello class, so in this video we're going to be talking about quadratic inequations. But before we start looking at quadratic inequations, I want to begin by looking at linear inequations. So let's say we're given this inequation, x plus 1 is greater than 0, and we want to find what my x values could be that this would be true. Well, in order to do that, I could approach it two ways. I could either solve it algebraically or graphically. So let me begin by doing it algebraically. So to do that, I'm simply solving in essence for x. So I'm going to minus 1 from both sides and then go, well, that's going to be x is greater than negative 1. So as long as my x is greater than negative 1, this inequality will be true. And I could test that out by subbing in a number greater than negative 1. Let me say 0. 0 is greater than negative 1. So 0 plus 1 should be greater than 0. Well, 0 plus 1 is 1. And 1 is greater than 0. So that's true, which means that's true, which means this is true. It works. Another way I could approach it is by doing it graphically. So what I'm doing is I'm graphing this, y equals x plus 1. And that's going to look like this. It's going to have a y-intercept at 0 and 1, and it's going to have an x-intercept at negative 1 and 0. Now, what I'm trying to find is where x plus 1 is greater than 0. So what number could I put into my x spot that my y would be a positive number? Try to think about it that way. What number could I put into my x spot that would get y being a positive number? And we know that if my y is a positive number, it's going to be everywhere above my x-axis. So if I was to draw that, it's going to be all of these values on and on and on into infinity. And we know that we're going to get these outputs when my x value is greater than negative 1. It's not going to include negative 1, but it has to be greater than negative 1. So I could write that as my x being equivalent to negative 1 to infinity. And that's exactly what we saw here. That is the same as that. X is greater than negative 1 is exactly the same as negative 1 to infinity. So here you've seen a linear inequation which was solved algebraically and graphically. Let's now move on to a quadratic inequation right here. And let me just go straight to the punch. You're never going to do quadratic inequations algebraically. It's just simply too hard. You're always going to do it graphically. So if I was to show you why you don't do it algebraically, let me just do this one quickly for you. So here's our inequality, x minus 3 is greater than 0. I could break this up into two parts. I have this part here, let's call it A, and I have this part here, let's call this B. So now I have to ask myself the question, what would have to be true about these two numbers that would give me a positive output? And what we're going to find is that we have two options. We have option 1 and we have option 2. So let me start with option 2. To get a positive number out, A could be greater than 0 and B could be greater than 0. And we know that to be true because if I was to times two positive numbers together, I would get a positive number out. No mystery there. But for option 1, my A could be less than 0. And if my A was less than 0, my B would have to be less than 0. Because if I times together two negative numbers, I'm going to get a positive number out. So either one of these could be true. So now I could do a bit more exploring. If A is less than 0, well, my A is my x, so x would be less than 0. And if b is less than 0, then that would mean x minus 3 is less than 0. And I could do some rearranging. My x would have to be less than 3. Then I could come over here, and if my a is greater than 0, that would mean that my x is greater than 0. And if my b is greater than 0, that's going to mean that x minus 3 is greater than 0. And I would do some rearranging and get x is greater than 3. So now I've got these four things before me. I have x is less than 0, x is less than 3, x is greater than 0, and x is greater than 3. Oh boy. Okay, now we could say, well, if x is less than 0, then it's automatically less than it's automatically less than 3. So we really don't have to worry about that because if x is less than 0, it's by default less than 3. And so too over here, if x is greater than 3, then it's automatically by default greater than x is greater than 0. It's greater than 0 if it's greater than 3. Nothing too mysterious there either. So we would be left with this. I could either have x is less than 0 or x is greater than 3. These would be my two options, and I could say that's my final answer. That's one way to solve a quadratic inequation. As you can see, it isn't the most elegant way to do it. A better way to do it would be to write this out. I could say, well, this is y equals x minus 3, and I could graph it. So this would mean that I have an intercept here at 0, and I would also have an intercept here at 3. I would then give that a quick sketch like this. Oop, that's a bit wonky, but it will do. And now I'm asking the question, where are my outputs greater than 0? Or to put it another way, what would my x's have to be that my y would be positive? Well, I know where my y's are positive. It's everywhere above my x-axis. So it's going to be here, and it's going to be here. That's everywhere where my y's are positive. And we know that my x values, which correspond to these regions, will be everything less than 0 and everything greater than 3. So therefore, if I was to write it out just by looking at this graph, I could tell you that my answer is going to be x is equivalent to negative infinity, 0, with the union of 3 to infinity. And notice that I have my circle brackets, well, my round brackets, because it's not greater than or equal to. And hopefully what you can also see is that these two answers are the same. X being less than 0 corresponds to this part of my graph and is negative infinity to 0. And x being greater than 3 corresponds to this part of my graph in which it's 3 to infinity. But hopefully what really sticks out to you is that it's far easier doing it graphically than it was doing it algebraically. And as we go through some more questions in future videos, we're going to purely do it graphically. But let's now look about what's written in your notes. So we're told how to solve a quadratic inequality. Your first step is to rearrange so that the right-hand side is 0. We're then going to sketch the graph of the left-hand side, solving y equals 0 to find the x-intercepts and paying attention to the concavity of the graph. We'll be seeing that in future videos. We're then going to state the range of values of x, which give the correct range of the graph for the given inequality. So this is where it's either less than 0 or greater or equal to 0 or something like that. And then we have a very strong line here which tells us that you must sketch the graph to solve any inequality that is not linear. And that's also what we're told here. So this is taken from the textbook. When solving quadratic inequalities of this form, it is best to sketch this graph. So hopefully that answers your question of how exactly we approach quadratic inequalities. In a future video, we're going to go through some more examples to really solidify this in your brain. Hopefully this helped.